Hi, I'm Oais. I'm a software engineer and I've recently started learning Go. I think the best way to learn something is by teaching it. So that's why I thought maybe I should start making videos on Golang because this is a relatively new language. This course will be loosely based on the book Learning Go, and I'm thinking it of making it in the form of a playlist of all the covering all the chapters of the book. So yeah, let's just start. For first of all, the introduction, Golang. Golang is a relatively new language which many new startups or new tech companies are being built upon. So this is a very hot time to learn Golang. So yeah, I'll just start with it. Uh, Built-in types, just like all other languages, Golang has built-in types. So great. So you don't have to worry much about what are these statements right now, import MFT and all of this. First, yeah, let's just start with boolean. So boolean are just basically the flag like true or false. Integers is basically numbers like 1 comma 2 3 4. Float is basically the double double as in Java, but like 1.1, 1.30022, and then we have string that is like ABC or XYZ. So these four are the built-in types. Great. So now let's moving on. So every language has a zero value attached to it. Like whenever, let's say, you initialize a variable and let's say you don't assign a value to it, you get a value by default, right? So let's just see how does the by default value work. Let's say I'm initializing a variable var x int. Yeah, and now I'll initialize a variable where, oh wait, I'll just make it abcd, so that will be more helpful. Correct. B stands for like abcd, a int, b boolean or bool in this case, where c string, or where d float 64. Float 64 basically means 64-bit 4-digit number. And now I'll just print, so we'll just print the default values, that is integer default value a, right? Similarly, we'll just do it for b, c and d. Yeah, this will be the boolean default value. This will be the string default value, and this will be the float default value. Great. This will be d. Notice all the red markers here. We'll talk more about it later, but it usually tells us that if a variable is not being used in Golang, if a local variable is not being used in a Golang, it generally throws an error, a compilation error. That's how it makes sure that we don't declare a variable that we don't want to use. Great. Great. Now I'll just try to run it. Wait, yeah, I'll just run it with go run main dot go. Great. So now, as you can see, this is how I this is how we run the program in Go. And this is basically a command go run main.go. It basically builds the binary file and then executes it and removes it also. You can also do go build main.go. It will just create the binary file, right? So integer default value, as you can see, is 0. Boolean is false, string is empty, and float is also 0, right? So these were the 0 values. Now we'll just start talking about literals. So what is a literal? Literal, you can think of something that has a value, or let's say, suppose if I'm talking about color is a variable, then red, yellow, or green will be the literal. That is the actual value that is assigned to something. So in the as I've attached the screenshot, in programming, a literal is a notation that represents a fixed value directly in the source code, like the number 3 or the string hello. Correct. Yeah. Now, types of literal, there are 4 types of literal. There is also a complex literals, or there is also a complex type of variables, but I think that's beyond the scope of this course. So we have integer literals, floating literals, Rune literals, and string literals. So we'll just talk more about it. Great. So now, first of all, let's just talk more about integer literals. Right. So now, let's say I have a variable like this. Let's just represent it like this: fmt.println integer literal, and then uh, let's just not talk let's just not dive deep right now into this, how I am initializing the variable or how I'm declaring it. We'll see it later, but yeah, let's just focus on this, how this is an integer literal. So as you can see, just run the code. Yeah. So now let's say I want to add I want to write a big number, like something like a phone number, like 1 2 3 4 5 6 7 8 9, and then I'm printing it. As you can see, I have been able to print it, but let's say I want to increase the readability of it. I can add the underscores in between the literals and it will be treated the same way. So we can use the underscores just to increase the readability, but make sure that you are not adding underscores at the starting or similarly at the end. This is not a good, like it will give you an error. Great. Let's talk about floating literals. Floating literals are decimal points that just indicate the fractional portion of the value. So it is very similar to the integer literals, just that we have the point or the decimal also. No, wait, I don't think that it requires much explanation. Great. So let's just talk about the Rune literals. So Rune literals are like the Unicode for characters. Like if they store the Unicode value of a character. Suppose, let's say we have a, the Unicode of it is 97. Yeah. So let's just see how they work. Great. So let's say if we have a is equal to a, this is the Rune assigned to it, and then if I print this Rune literal, and then I print this, when I'll just run this command, it will show 97. Yeah, but suppose I want to get the string of it, so I'll do string yeah. Now when I'll hit the run, it should do the it should return the string value of the Rune, that is a. Cool. Now what if I just try to add more characters to it, ABC? It just throws an error because it accepts only one character. Great. Now the last, string literals. So string literals are basically multiple characters, or like a sentence or like a word. Basically multiple characters is our strings. So let's just talk more about it. Great. So I think there are 2 ways to indicate string literals. Most of the time you'll use a double quote, like, wait, yeah, so most of the time you'll use a double quote, string a, sorry, yeah, most of the time you'll use a double quote, like a is equal to greetings and hello. Sorry, I missed this. Now if I print it, uh, string a. Now if I run this, I get greetings and hello. There's also other way, but that way is known as raw declaration or raw strings. If I declare it using raw strings just by this back quotes, I get greetings and hello the same way. The problem comes, or the difference comes, when I start doing this. Let's say I want to insert this in a new line. So when I run this command, this will be greetings and hello in the new line, right? But let's say I want to interpret this as a raw string only. Like I want to keep these escape statements. I just want to keep them. I don't want to use their functionality, but I want to keep them. So now when I'll use this, I'll get this. So this is the main difference between raw strings and double quotes, right. And adding to the integer one more thing. Go is very strict with the type of variables that we are using. So suppose we have like 4, and suppose we have p in 64 is equal to 8. Now let's say I just try to do a plus p. This will always throw an error because we need both of these types to match. This was there on top of my head, so I remembered it. And also, what does this mean is that literals are not that this means, but generally literals are untyped in Go because it makes sense to avoid forcing a type until the developer specifies one. So suppose the same number that we had var a is equal to var a int 32 is equal to 2, and the same number can be sorry, and the same number can be represented as a sorry, why am I doing this? Yeah, and the same number can be represented as a N64 number, and the same literal can be represented as a float 32, and similarly the same number can be represented as a float 64, right? Great. So next we have is integer operators. So integer operators are nothing, basically they like plus minus sign and the negative sign and also the bit masking sign. So we also have that functionality in Golang. The integer operators. Suppose let's say I have where c is equal to 3 plus 4, 3 plus 4. So let's suppose I just have var c is equal to 3 plus 4. This is a integer operator, 3 into 4, and similarly divide by 4, and then similarly what's the other, plus minus 4. So these are the 4 integer operators. You can also use shorthand operator for them, like var c is equal to let's say initialize it by 4, and then sorry, my bad. And now all I do is let's see, c is equal to 4, and then I'll just try to print c. Let's see what it prints. Yeah, great, it prints 16 because this is also a notation for c is equal to c into 4. This is a notation for this, so these are known as shorthands. I'll just try to run it. Yeah, 16. So these are known as shorthands. Great. So now we can also do the bitwise operation like left shift and right shift. Left shift means suppose this number is like this in binary format, and let's say if I do left shift, it shifts. Wait, I'll just try to be more diagrammatic. 3, correct. So now currently let's say the number is like this. Wait, yeah, I'll be try to be more diagrammatic. Let's say now the number is like this. 1 0 0, and if I do left shift it will be 1 0 0. Basically it pushes the number towards the left by 1 bit or whatever you specify. And now let's say if I do the right shift, it will be like this. Correct. So this corresponds to 4, the original number. This corresponds to 8, the left shift number, and this corresponds to 2, that is the right shifted number. So let's just try this. Great. So now I'll just do c is equal to 1. This is left shift by 1. Sorry, yeah. Now I'll just print ln c. Great. If I run this, we'll get left shift 8. Right. Suppose let's say if I do right shift and do the same thing, we'll get 2. Yeah, so this is left shift and right shift in Golang, and I'm doing it using the shorthand operation. You can read more about it. Great. So now let's just talk about floating points. So floating points are basically, there are two types of floating numbers. One is float 32 and one is float 64. One thing to note here is that floats aren't exact value matches, aren't exact value matched, because suppose you have a limit from 10 to the power minus 325 or something to 10 to the power plus 325. You won't be having enough memory to access all the numbers within this range, considering that they will also be having the decimal numbers. So the values are not an exact match. I have an example for this. Just bear with me. So suppose we have where x, y float 64 and x is equal to 0.1 plus 0.2, and then we have y is equal to 0.3, let's say many zeros, and then 7, right, or 1, right. So now what I'll do is if x equal y, we'll just do, yeah, and similarly else x is not equal to y, right. Great. So now I'll just try to run this function. Let's see how it goes. X is not equal to y, correct. But let's say if I start increasing the number of zeros before the 1, I think we'll have to really increase the zeros, because I think the difference that it considers is the epsilon that it considers is roughly like 1 into 10 to the power minus 17. I'm not sure about this, but this is roughly the epsilon that it takes. So as you can see, these both values are not exactly true, but since we are using this operation, so exact equal to operation, so the Go treats that as true and basically checks this condition. So what you should generally do is you should just make a difference within something like this, and you can just subtract both of them and just get the difference that is there. Yeah, I think that is like you can just compare it to a threshold. I think that's a better approach for this. Great. So now let's talk about strings. Um, in the string literal section, I did tell you and did show you how strings are and what exactly are strings. But now let's just talk more about strings. Uh, yeah, let's move to the code. So first of all, strings are immutable in Golang, and the main reason for one of the main reasons for that is memory management. Suppose you have a string, let's say uh, string a uh, sorry var a string is equal to, let's say, hello, so, and var b string is equal to hello also. I don't know why it did hello world. Both of these variables can both of these variables are pointing to one hello that is there in the memory. It doesn't have to make multiple copies of hello. And let's just show the immutability of the of strings in Golang. So suppose I have an original string as hello world, or original, I'll just keep it original one, and then if I try to do F15, uh, so this is the original string. Now let's say if I try to change it, let's say if I want not to be original one, or I want the first letter not to be O or something else, I'll just do original string uh, 0. um, I'll just make it Y. I just see cannot assign to original string. Why? Because this is the immutability of the strings. uh, uh, let's say if you want to modify this, or you want to add something on this, what you can do is additional string is equal to uh, added and then plus original string. So I think that will work. If you try to print that, just delete it. So now if I just try to run this, it will print original one and then added, no space. I think I should add the space here. Got it. Let's just see. Yeah, added original one. As you can see, the strings were immutable, but you can use the original string and you can use it to concatenate or to add more strings to it, but you can't change the original string. That is what immutability is, right? Now explicit type conversion. You must use a type conversion when variables don't match. Uh, as I've shown you earlier, that the different integer sizes weren't compatible. Uh, like there wasn't any implicit type conversion. So you have to make it clear in which type of conversion do you want. Let's just talk about variable declaration. So up till now you must have seen that I'm sometimes declaring a variable using var accent, and then all I'm doing is x semicolon equal to. So let's just talk more about why or how this works. Yeah. So the var accent was the most frictional way to declare a variable. We explicitly specify what type of type do we want for that variable. So as I've shown you, var accent is equal to 10. So that was the most what do I say? That so that was the most frictional way. Let me show you through the code. Wait. Right. So most frictional or most verbose, whatever you want to say, var accent equal to 10. This is the most frictional way to declare the variable. Uh, now, if the right hand side is of the type the variable that you actually want it to be. Like this is 10 is int. uh, you can just do y is equal to 10. Easy way. But let's say if this has to be 64, you can't do it using this. Now let's say if I try to add x and y, it won't be added because 10 is int by default. If you want to let's say make this in 64, and then you can do it. Oh wait, yeah, now it won't give an issue. So in this also you can actually typecast it, but if you don't provide anything, it just takes the default value, right? So also you can declare a variable, multiple variables using the same approach, and also different variables. So where x comma y is equal to hello and then 1. So yeah, just change the name of this. So you can do multiple variable declaration. Great. In this both the type was same, and this, both the types were different. What usually is done whenever you, let's say this I learned while working only, let's say block of variables, we'll just do var and sorry, and then just do x and 10 y float 32 something 2.5, and then z string hello. Yeah, so you can declare a block of variables using the same thing, using this approach. The short declaration format is, as I told you earlier, using the semicolon and equal to operator. It replaces the var declaration. The two majorly are more or less similar. But I'll try to show you the difference between them. The major difference between them is, suppose you have var x y equal to 10 comma 20, and now let's say you have var a comma x equal to 10 comma 30. So now let's say I'm printing everything, a comma x comma y. So ideally there shouldn't be a problem, but what I'm facing the issue is x getting declared. So let's say if you want to prevent any variable to prevent it from getting redeclared, you can use this. Now let's do the same but with the shorthand, right? So now xy this, and then now it doesn't show an error, it just shows the small warning on just some sort of an, yeah, never mind. So now you are able to redeclare it. Now let's just see what it prints. Yeah, sorry, yeah, sorry for the slash. Yeah, 10 30 20 expected. So this x value got updated. So this was the variable declaration. Now we'll move on to the const keyword or the constant keyword. So const keyword is basically used to initialize variables whose value doesn't change, or if, let's say, if you try to change it, it throws an error. Yeah, so I'll just in a way it is just like declaring the names to literals. Suppose you want one but in a form of a variable, so you can just do one is equal to 1. I'll just show it in the code, just wait a moment. Yeah. So yeah, let's just remove it. Let's say I have my const here. Const, let's say, suppose number of tries, 3. Right. Now if I do fmt, why the fuck is this? No. Suppose now, if I do number of tries, it will just show 3. Correct. Now if, let's say if I try to change it, it won't. Yeah. So now if I try to change it, it won't allow me. Let's just try. Number of tries is equal to number of tries plus 1. As you can see, it's not allowing me to change. So that is one use of the cons, that it does not allow you to change the variable once it's declared. And suppose there are multiple usages of this number of tries, and you have to just change it once in this code, and all the other changes will be applied to every other area where this is being used. Unused keywords. So as I've shown you earlier, when let's say you weren't able to, yeah. So as I have shown you earlier, another that Go requirement is that every declared global variable must be read. Otherwise, it gives a compile time error. Although it does not give when you're using cons. Let's say you have declared 10 constants and you are using 4 of them. It's all right. It doesn't throw an error for that. Also, the Go compiler won't stop you from creating uh, unread package level variables. It only has this feature for the block level variables. So suppose you have package level variables, it's okay with that. Now, so now this marks the end of the course. I'm still relatively new to all this. So any form of comment that let's say you have to this is more than welcome. I'll try to improve on it, and I'll try to be as regular as possible. So guys, bye bye, see you next time. And if you like this content, you can just subscribe to it.